Hello, my name is YANG2PY and I'm the lead developer of Netconf Yang products here at MG-SOFT. In this short video presentation, I'll be presenting our new product called Netconf Yang Python scripting system. First, we'll go through a couple of details, and then I'll show you a couple of examples to demonstrate the system in action. First, a few basic facts. Our solution represents a Netconf client scripting framework. It provides everything you need to create a Netconf client. You can use it to create automated tasks or use it as a testing tool. It uses existing infrastructure from MG-SOFT used in other products such as Netconf Browser, and its base implementation is written in Java. We use Yang to make the scripts data model aware, as I'll demonstrate a bit later. We decided to use Python as the scripting language of choice for the system, mostly because it is really popular among developers, it's extremely flexible and has been around long enough to have a mature tooling chain. The intended version of Python to be used by the system is Python 2.7, which is also the most widespread. We are also planning to support RESTconf and JSON in the near future. Here we will see an overall diagram that demonstrates the usual workflow when using the system. I'll introduce the blue squares on the diagram in more detail in the following slides. We start with a Yang module set, which is determined by the target Netconf device. We feed the Yang module set to one of the tools provided by MG-SOFT called YANG2PY Generator, which generates code for each of the modules in the set. The generated Python modules are used by end users when creating Python scripts combined with another part of the system called Netconf Scripting API. This API enables a script to communicate with a device through Netconf protocol. So let's take a quick look at YANG2PY. YANG2PY provides programmatic access to a Yang data model by generating data binding classes for it. It's somewhat similar to what JAXB does for XML schema in Java. It makes Python code data model aware. YANG2PY consists of two parts, the YANG2PY Generator and the YANG2PY API. The YANG2PY Generator is a graphical user interface tool that generates Python code from valid Yang modules, and the YANG2PY API is an API that provides some base classes for the generated code, and also provides a utility API that is used by end users in Python scripts. YANG2PY Generator analyzes Yang and generates data binding classes for it. It attempts to generate readable code that reflects as much of the concepts used in Yang as possible. For example, a single Yang module is mapped into a single Python module. Python modules import each other as Yang modules do, augmentation is realized in the same way, and definitions are used in the same way as in Yang, for example type usage. All the documentation found in Yang modules is also retained in the generated Python modules to make their usage easier. The generated code is then used in Python scripts by the end user. I will show you the tool and the generated output before we go on with the examples. As already mentioned, the YANG2PY API provides some base classes used by generated code and a utility API to be used in Python scripts. The latter provides means to serialize data binding class instances into XML and deserialize XML back to data binding class instances. It also validates the class instances during the serialization and deserialization process. Everything you need to make a Python script Yang model aware is provided by the two parts of YANG2PY. So now we've gone through the first blue box in the diagram, and now we'll proceed to the second one, the Netconf Script API. The Netconf Script API is a Python wrapper around the existing Java Netconf stack implementation, which supports both versions of Netconf over SSH and also Netconf over TLS. The main purpose of this API is to provide Netconf connectivity to Python scripts through classes such as Simple Netconf Client and Operation Builder, which I'll demonstrate when we go through the examples. Here I'm going to show you a diagram of the system's overall architecture. The YANG files and the device are provided by the vendor. MG-SOFT provides the YANG2PY API and the Netconf Script API. You then use a Python IDE or a similar tool to create Python scripts that utilize the two APIs to manipulate a Netconf device. This was a quick overview of the system. We will now go through the examples. We've used Eclipse to create these examples, and I will also use it to show and run them. All you need to do in order to run these examples is to install some modules into your Python instance, have a Java runtime environment installed, and set a couple of environment variables on your target system. The first example is a really simple script which utilizes the model defined in ietf-interfaces YANG module, which contains a collection of YANG definitions for managing network interfaces. Let's take a quick look at the code that was generated for it by YANG2PY Generator and how it was done. This is the YANG2PY Generator. You load YANG modules into it, select a Python package name, a destination directory, and use the generate feature to generate Python binding classes. The package name is the entry point in your end-user scripts to reference the generated classes. Let's see what was generated for the ietf-interfaces module. I'm going to show the original YANG file on the right and compare it with the generated code. As we can see, a class was generated for each typedef, identity, and if feature, in the module. The more interesting part of the module, however, is its data tree. The data tree is represented as a class hierarchy where each node is mapped into a class or a class attribute. This class hierarchy closely resembles the original YANG file. Some of the names may have been mangled a little. For example, like we see here. In order to comply with Python syntax and best practice requirements. But we can still see the interfaces container, the interface list, and its properties. Interfaces container, the interface list, and the properties of an interface. Now let's go back to the example script and go through the details of it. This script connects to a device and lists all interfaces configured in the candidate datastore of the device. Before going into the details of the code, I will first run the script so we can see some output. As we can see in the output in the console, this script simply issues a GetConfig operation and parses a response to it. The two APIs that I mentioned in the slides are used in Python scripts by importing them using Python import statements. Here we see an import for the YANG2PY API, and here we see an import for the Netconf Script API. There is also an import that references the code generated using the YANG2PY Generator, where we import the ietf-interfaces module, which we went through before, and the ietf-NetConf module, which defines the classes that represent the Netconf messages layer, for example, the RPC and RPC reply, as we can see here. There is also a bunch of other classes that represent the base Netconf operations, which were present in the ietf-NetConf module, for example, GetConfig, EditConfig, and so on. The next important part of our script is the creation of a simple Netconf client object. This object will let us control a single Netconf session and is part of Netconf Script API. It lets you control the Netconf session by using its connect, send RPC, and disconnect methods. So in this particular script, we first connect to a Netconf device using the connect method of the client object. We need to provide authentication information through arguments to this method. So here we see a username, a password, a host name, and a port that has to be specified, and we also specified the SSH2 protocol to be used for communication. Next, the script creates a request, which is what we see in the console down here, this part, and it does so by utilizing the generated binding classes from the ietf-NetConf and the ietf-interfaces modules. This code here actually creates the filter element of our request, as seen here, and it does so by creating instances of our binding classes, and then after the instances are set up correctly, it marshals them or serializes them into XML by using the marshal method, which is a part of YANG2PY API. So this object here is actually serialized XML. This object is then used as an argument to a method from another useful class from a Netconf Script API, which helps us to form a full request, not just the filter element. So we utilize the create-get-config method of this class and specify our filter as the filter element of the GetConfig request. The request object is then used in an argument to a method of our client object sendRPC, which is a blocking method. It blocks until the device actually responds with a response. So this object here, it will contain the response of the request. Next, we need to parse the response and do something with it. We parse the response by using another method from the YANG2PY API, which is called unmarshal. You specify the response object as an argument to this method. You also provide the starting point, the starting generated Python module, where a lookup will be done for classes that match the content of the response. So all we have to do now is to traverse the structure of the returned object. We do so in the part of code here. So as you can see, we first reference the RPC reply object and then its output GetConfig. Because we know what to expect, since we created the request, we expect the result to be a output GetConfig member of the RPC reply. We also expect it to contain the data object, the interfaces object, and then a list of interfaces, which we go through using this statement. So what this part of code does is actually it loops through all of the interfaces that were reported back and simply prints them to the console. If in the event that no interfaces were configured in our candidate data store, it would print out no interfaces found. As we can see, the script not even once mentions any XML. It does not define any XML strings or use XML files. It simply utilizes the generated binding classes to both specify a request and then parse a response. You can use the IDE's autocompletion feature to create code like this. However, when traversing the parsed object by the unmarshal function, you will have to get a little bit creative. Since Python is a weakly typed language, the IDE cannot know what this object will actually hold until this code actually runs. So if I try to use autocompletion to access members of the object, like so, you can see that the IDE does not suggest any autocompletions, but you can get around, or you can work around that by fooling the IDE and by using the code that would be used to instantiate the expected reply. So for example, I know that the reply will start with an RPC reply element, which will be parsed into RPC reply. If I try to use autocompletion on this object now it will suggest the possible members for the object. You would use this workaround, as seen in the comments here, to use autocompletion to finally get the final statement that is actually used to loop through returned interfaces. After the script is done with its work, you just need to call the disconnect method of the client object to close the session and then exit the script gracefully. All of the scripts, example scripts, which I'll show you next, use a very similar template. So on to the next example. This example complements the current example which I just showed you, and it demonstrates how to issue an edit config operation. We previously issued a GetConfig, and now we'll issue an edit config. So if I run this script, we can see that we created an edit config operation that will add an interface into our candidate data store. You can see that the operation was successful since the device responded with an OK message. Again, we connect to the device using the simple netconf client object. Then we create the request. This code here creates the config element, which can be seen in here. Again, by utilizing the generated binding classes. It then marshals this object into XML and is then again used as an argument to another method of the operation builder helper class that will create an edit config request, which we will send to the device. We send it using the sendRPC method of our client object, and then we parse the response. This response is a little bit simpler to parse because we only expect an OK or an RPC error to be returned, and depending on that, we simply print the test result as a string, which we see at the end of the script here. After the work is done, we simply disconnect the client and exit the script. So now let's demonstrate that these two scripts actually affect our device. So the previous script lists the interfaces, and it always lists two interfaces. And since we use the create interface script to add the ETH1 interface, which is already in the candidate store, it is always merged in there. So let's now create a third interface and run the script. And we run the previous script. It should now show three interfaces in our candidate data store. And indeed, there is now the third interface in there. So the two scripts actually did affect the device. So let's go on to the next example, the get schema example. This example is similar to the previous two ones, with the exception that we specify the request using an XML string. So we specify that this script should obtain all available schemas in netconf state of the netconf monitoring module that is also provided by the ietf. So let's run this script. So basically it requested all the available schemas on the device and it then listed them. Now it's awaiting input a number from 1 to 15, after which it will dump the requested schema to console. So if I select the 10th entry, which should be the ietf-netconf module, and confirm this, we can see that the script obtained the ietf-netconf YANG module that is present on the device. The next example demonstrates how a script can handle netconf notifications. This script actually creates two netconf sessions. The first one here. It connects with the first session and then issues a create subscription operation, which means that it is now subscribed. If the operation is successful, the session is now subscribed to netconf notifications. The second client or netconf session is then created, and it issues a couple of netconf operations that are sure to generate netconf notifications. So it first issues a confirmed commit and sends it to the device, and then a cancel commit that is sent to the device. So let's see this script in action. I'm simply going to run it. And as you can see, there were a couple of notifications generated and some information was extracted from the notification content and printed to the console. So let's see how this script achieves this. The important part of this script is right over here. Here we see a class definition which extends netconf notification listener, or a class which is provided by the Netconf Script API. You need to implement this interface in order to actually receive notifications. So all notifications that are received during a subscribed session will be sent as a callback to this method, notification impl. In here, you process the notification accordingly. So, for example, here we simply parse the notification and, depending on the type, print out different information. For example, a session start notification would have a session ID, username, source host, and so on information. And for example, a confirmed commit, like here, would have a confirmed event, a username, and event time, for example. So this shows you how you can handle notifications after you have defined such a class, an implementation of the notification listener interface. You simply instantiate it and add it to the client that is supposed to receive notifications. All of the examples we've seen so far have used the simple netconf client object to create a session. The next example will show you an advanced version of the simple netconf client. It is called the async netconf client. This implementation can handle several netconf sessions at the same time. In the same manner, we've just seen notifications being handled. So every event related to a netconf session is reported back as an asynchronous call. You receive the calls in an implementation of the async netconf client listener. This is an interface you need to implement in order to receive different events that are related to a netconf session. For example, here you can see a connected successfully, a callback, a connect failed, a disconnect success, disconnect failed, RPC reply received, and so on. Also, there's a callback for notifications, which is the exact same one as we've seen in the previous example. After you define an implementation of the async netconf client listener interface, you simply provide it as an argument to the constructor of the async netconf client. So all of the events will now be passed to this implementation. So what this particular script actually does is that it queues all of the events that it receives into a single queue in order to synchronize them, all of them, and then it simply loops in an infinite loop and processes the queue. So it processes the events one by one, and depending on the type of the event that we received, we react. So for example, this script creates a first session, and then after it is successfully connected, notifications, yes, it spawns 100 different sessions, which all, after they also connect, simply execute a simple query, which is a GetConfig operation. So there will be 100 sessions that all issue a GetConfig operation, and then after they issue the request, they simply disconnect, and all of this is logged in the console. So let's try to run this. We should see a bunch of input of output when I run this script. So first the sessions were created and connected, and then they sent their query, and then the response was checked, and all of them reported the response was okay. So this is how you would implement an advanced version of the netconf client. It's a little bit harder to implement than simple netconf client, but this is much more powerful. This was the last example we have prepared, and I hope you enjoyed this quick video and are excited as much as we are about this new product by MG-SOFT. Thank you. Goodbye.